We are live, sir. You can start, sir.
Welcome everyone. Welcome to the Gate Academy channel. A very welcome to all of you on the Gate Academy channel. So my dear, in this session we are continuing with the live quiz of fluid mechanics, right? So what we are going to do, we are going to continue with the live quiz of fluid mechanics. So prior to this session, we already had 3 quizzes done, right, my dear? We already had 3 quizzes done in this series, and now in this FM series, this is the 4th quiz, right? This is the 4th quiz. So I hope you guys have attended the previous sessions as well. Have you guys attended the previous session? I hope so. So those who are live can tell me in the chat a hi or a hello or something like that, so that I know. Amati, you can try the quiz, na beta? You can try the quiz, right? So, my dear, first of all, before starting with the session, I would like you to like and subscribe the channel if you have not done it yet, because we are continuously coming. Hello, Ambati. We are continuously we are continuously giving you some good videos, some good interactive sessions, right, my dear? Right, my dear. So let's, without wasting any time, let us start with the quiz. Okay. So first of all, Ambati, you can see the link on the screen, beta. bit.ly TGA035E. So the first thing that you guys have to do, you have to open this link. Okay. So if you are watching this video, if you are watching this video on the laptop, you can open this link on the mobile. You can do the vice versa also. Means if you are watching this video on the mobile, you can open it up in the laptop. Okay, if you are using a laptop only, you can open this link on the second any other window. Or if you are having only mobile, then you can use the split screen option available in the most of the mobiles, right? So first of all, beta, I request all of you to join the link. You have to go to the link, register yourself. Okay, and registering doesn't require much to do. Just you have to write your name. So a small request from our side is that you give your real name, beta, here. Okay. Okay, please give your real name here. Do not just write any random name. Okay, please give your real name so that we can address you and we can see to it. Okay. So now in this quiz, first of all, how to play the quiz. So I already have explained that you have to join the link. You have to give yourself a name, and then you can start playing the quiz. Right, beta? Right, beta? And there is no negative marking in the quiz. Okay, there is no negative marking. So you must answer, or you must try to answer all the questions. Right, beta? Right, beta? So along with each question, some point will be there. Ambati, you can see the link, beta. It is bit.ly TGA035E. You can see the link on the top of the screen in the red. Right, beta? So you can type this in the window, and you will have the slides in front of you. Right, my dear? So obviously, tougher the question, more will be the points, and also here the points will be dependent upon 2 things. One is your answer must be right, and secondly, you should answer it as quickly as you can. So sooner you answer, more points you will get. So idea behind it is simply, in any competition, we need to answer in the limit of time also, right? We just cannot have or cannot use much time in every question. Okay, so in this quiz, you will be seeing your comparative ability of solving questions in time limit also, right, beta? So now we are going to start with the quiz. I hope all of you have joined, right? So let us start the quiz now. Let us start the quiz now. Okay. So Keshav is there. Teja is there. All right. So any student who have not yet joined, Ambati, as I said, you can see the link at the top. Okay. So here we go. The first question. Ambati, you have to write your name. Just you have to write your name. Oh, you have not joined yet. Amity, please write bit.ly tga035 hash 035e. You see it in the red beta. It is in the red and you have to write this. You have to write this. Right? You have to write this and a link will be opened. Okay, a link will be opened. Okay, and there you have to name yourself. Just do it quickly. So so this is the first question, my dear. It carries 52. So I have also written the link in the chat also. So you can directly copy this, Ambati, and can join. Okay, so you can directly copy this thing and can join. I have written it in the chat box, Ambati. Please copy it and open it. And any other student who have not yet joined, please join the quiz. Okay, so this is the first question. Okay, it is a MSQ question, multiple select question, my dear. So here the solutions will be more than one. You will have to select more than one answer, right? So more than one answer is correct in this case, right? Right. So this MSQ question is the new addition from GATE 2021. Okay. And in this, you have to select multiple options, right? So in this MSQ kind of question, more than one options are correct. So you have to select all the correct options in order to get the right answer. So please answer it. Time is running out. We are left with 50 seconds. We are left with, so here you can see one more link is there. Link is there, beta. Link is there in the chat box. Please join. If anybody of you have not joined yet, please go for it. I can see more students in the YouTube live, but I can't see more people in this chat. In this quiz have joined the quiz. Okay, 3 of you have answered. Please go for it, beta. It's a very simple question of boundary layer analysis. Today is the topics that we are going to see questions from is boundary layer theory, right? Right, my dear? Okay, please join it. Okay, so we are running out of the time and the time is up. Okay. Okay, so it seems none of you have completely given the correct solution to it. Okay. Okay. So, my dear, none of you have been able to select all the correct options, right? Some of you have got few correct options, but still few correct options was not there, right, my dear? Right, my dear. So no one of you was able to answer this question properly. So what we'll do in the end of the quiz, so we will go question by question, and after the end of the last question, I'll discuss it. Okay. After the end of the question, I'll discuss it. Okay. Now here we go with the second question. Please try to solve it carefully. Please go for it. It is a question from dimensional analysis. It is a question from dimensional analysis and it is a MCQ question. Now, what does MCQ question mean? So, MCQ question means that MCQ question means is that in which you have to. No problem, Ambati. You can start from the second question. You can start from the second question itself. No problem at all. Please go for it, my dear. Definitely you can do it. It's a very simple question of dimensional analysis. I hope you guys remember how we solve a question of dimensional analysis, my dear. Okay, so we got 2 answers till now. See, in these kind of a question can come in the GATE examination in 1 or 2 marks, right, my dear? In 1 or 2 marks, these questions can come in the examination. Okay, please try to solve it. I am very sure that if you try, you will be able to do it. Please go for it, beta. Please go for it. Definitely you can do it. Definitely you can do it. If you try, definitely you can do it. Please try harder. Okay, so what this question is telling us, a shift model with scale 100 by 10 has a wave resistance of 10 Newton at its design speed. What is the corresponding prototype wave resistance in kilonewton? So it is a question of dimensional analysis and modeling. So we have a model, we have a prototype. So some data persisting to the model is given to you. So you have to find the corresponding data with respect to the prototype, right? So you have to relate, my dear. So I can see only 3 students have answers still yet. Please answer it. It's a MCQ question. In MCQ question, we have to select only one option. Okay, we have to select only one option. Please go for it. Please go for it. I'm very sure that we can do it. I'm very sure that we can do it. I don't think there is a problem in that. Please go for it. Please go for it. All right. So time is up and only 3 have answered, out of which 2 have answered correctly. So let us see. Okay. So we have the right answer from Teja and we have the right answer from Naga Srisai. Okay. Okay, so very, very good. So those who are unable to answer this question, please try in the next question perfectly. So the last question was of Froude model, if you remember. Right, but it is of Froude model. Okay, so let's move to the third question quickly. All right. Let us move to the third question quickly. So this is your third question here, beta. It's coming and it is a numerical ability type question. Please read the question carefully. So we have 4 minutes for this question. So please try this question perfectly. Please try to do this perfectly. I'm very sure that you can do it, beta. I'm very, very sure that you can do it. If you try, definitely you can do it. If you try, definitely do it. If we try, definitely we can do it. Take your time. Take your time. Read the question carefully. See, remember in the examination also, before solving the question, you have to read it very carefully. Please go by it. Go for it. So in a flow condition where both viscous and gravity forces dominate, and both the Froude number and Reynolds number are the same in the model and prototype, the ratio of kinematic to viscosity of model to the prototype is this. The model scale Lm by Lp is x is to 1. Find the value of x. Please go for it. Please go for it. I am very sure that if you try, you can do it, beta. It's a little bit trick is there. Not that much tricky, but still comparatively, it is a good question. And definitely, if it is going to ask in the examination, it would be asked in 2 marks. Right, beta? Please try. Please try. So those who have yet not joined the quiz can still join it by the link there. And we have a pinned chat also if you are seeing the chat box or on YouTube. So from there, you can join the link and start giving the answer in the quiz itself. Right, right. Please join the quiz if anybody of you has left to join. And also do not forget to like and subscribe the channel, my dear. Because see, we are trying this to help you out. So in a way, we mostly try to cover almost all the topics of fluid mechanics. Previous sessions we have covered dynamics, kinematics, statics, right? In the previous three quizzes, we have seen the questions from dynamics, kinematics, statics, and now in these sessions, we are seeing the question from boundary layer theory as well as Acha, Nagasri Sai. So you have answered. Okay, we'll see. See, if you are trying, you already have won half the battle. Okay, trying is the thing you must do first. Okay, and also those who are seeing the recording of it, I suggest them that they should do all these questions before. At in the end of the quiz, I start solving it so that you can also judge where you stand in the subject. Right, this is the sole purpose of these quizzes. So it is some sort of giving you quick revision also of this whole subject, right? So if any formula that is coming in your mind, okay, in this question, this formula should be applicable, but you are not able to recognize or reframe it. So then you should do some more practice. So please, those who have done this question, please answer. Only 5 seconds are left, my dear. All right. So again, I have got correct answer from none of you. Okay. I have got correct answer of this question from none of you. Right. The correct answer was 5 of this question. But I got 11.23 and 0.298. So don't worry, beta. We'll see. We'll see what mistakes you have done in the end of the question. In the end of the quiz. So in the end of the quiz, we are going to discuss all these questions. Yes, Ambati, the correct answer is 5 beta. We'll solve it. No worries, we'll solve it. So now again, Ambati, it is not like that, beta. It is not like that. Okay, we must try. That is the main thing. Okay, now this is the last question. Very, very simple question. Very, very simple question, and it is a MCQ question. So we have only one correct option for this. So I am hoping that all of us can solve this one. Please solve it. Please solve it, my dear. Please solve it. Let us see if we can solve it or not. Let us see if we can solve it or not. So this is a question of boundary layer theory. So in this quiz, we have 4 questions and 2 of boundary layer theory, 2 of dimensional analysis. So I am hoping correct answer from most of you, but try to read the question well. Try to do the question. Try to do this question. Definitely you can do it, my dear. Definitely, I'm very, very sure that you can do it. I'm very, very sure that you can do it. Okay, so only 2 answers I have got till now, beta. Please try to do it in less time also. See, sooner you answer, more points you will get. In exam also, see, if you can answer some questions quickly, you will have plenty of time will be remaining to you. So you can put that time in the questions that you feel are tough or somewhat tricky. Okay, so 4 answers I have got. Still some of you have not answered. Please go for it, my dear. Please go for it. Definitely you can do it. Definitely you can do it. If you try, definitely you can do it. I am hoping to get the correct answer from all of you. And beta, the purpose of this quiz is to make you make your revisions. Okay, it should be helping you in revising or making you understand that what is our situation in a particular subject. So we see many other subject quizzes are also running on the channel. So do not forget to subscribe it for the notification, right? And this is the last question. After this, I'll be discussing this. I'll be discussing all these questions one by one. So then you can see where you have made the mistake, my dear. Okay. Let us see. So 5 of you have answered. Still, some students have not answered. Okay. So everyone has answered. And we got 3 incorrect answers and 3 correct answers. Right? But now those who have given incorrect answer, I want you to read the question properly. A common classical mistake you have done, beta. A common classical mistake you have done. Right, my dear? Right, my dear? So let's see what is the leaderboard. So Teja. So Teja having the most point in this quiz, right? 151 point, followed by Nagasri Sai, followed by Jagan. So I think this last question, Jagan, Harsha, and Keshav, you 3 have given the right answer for this question. But this is a question of 100 points only. So that is why you get only 90, 76, and 51 points. Right, Beta? Right, Beta. So now let's solve these questions one by one and let us see what mistake we have done. What mistake we have done here. All right. So I hope you can see the OneNote now. So this is the first question. None of you have given the right answer to this question. Right? So which of the following statements are correct? So flow separation caused by positive pressure gradient. Right, Beta? So if you remember the separation, so separation happens when the pressure gradient is adverse, that is del P by del X is greater than 0. This is the necessary condition for separation. This is the necessary condition for separation. Okay. So I hope you remember this necessary condition for separation. So separation can only happen when del P by del X is greater than 0. Right, beta? Right, beta. Now reading the second statement, shear stress is 0 at the point where boundary layer separates. Okay. Boundary layer separates. So at the point where boundary layer separates, we know du by dy is equal to 0. So this is the sufficient condition. If you remember this topic, this is the sufficient condition. What does that mean? So if del P by del X is greater than 0, then there are chances of separation. That means separation can happen, and it will happen only when du by dy becomes 0. So we know tau is equal to mu du by dy. Now, if du by dy becomes 0, obviously shear stress will also become 0. So option B is also correct. Now, laminar sublayer exists in turbulent zone. So this is also a correct statement. So we know this is our somewhat boundary layer, right? This is our somewhat boundary layer. So in this turbulent region we have a laminar sublayer very close to the surface. When we read the turbulent flow topic, there is something called as hydrodynamic rough surfaces, right? So in there, we normally teach you, if you have learned from me, right? So I taught you in the chapter of turbulent flow that rough boundaries will be there if the roughness exceeds the height of laminar sublayer. So this is also true. C is also true. Now, suction of retarded fluid within the boundary layer is method to prevent the separation. So if you remember, in separation, why separation happens? Because velocity decreases, right? Decrease of velocity of the flowing fluid is the reason for the separation, right? Now, if we do the suction of retarded fluid, that means the fluid which is having very low velocities, right, or whose velocity is decreasing with the flow. So by doing the suction of them, definitely you can avoid the separation, because then velocity will not decrease, which is the main reason for the separation. So this is also correct. So in this question, all the statements were correct, right, my dear? So any doubt in this question, why any of you was not able to answer this? Some of you have given chosen two options correctly. Some of you have chosen 3 options correctly, but none of you have chosen all 4 options correctly. So can you tell me what went wrong in this question? Why you were not able to do it? So meanwhile, you tell me that I'll be moving to the next question. So just give me a moment. Huh? Just one moment. Some technical issue is there. Just one moment. All right. So I think you can see the screen back. Now moving to the second question, a ship model with a scale of 1 by 100 has a wave resistance of 10 Newton at its design speed. What is the corresponding prototype wave resistance? What is the corresponding prototype wave resistance? What is the corresponding prototype wave resistance? Right. So what we know, my dear, so it is a question of Froude model. What model, beta? It is a question of Froude model. What model, my dear? It is a question of Froude model. Okay, so in Froude model, how is the ratio of force is related? So it is related by the ratio of this. Yes or no, my dear? Right. So if you remember the analysis from the Froude model, the force is related by the cube of the scale ratio, that is LP by LM whole of cube. Now they have given this model force is 10 Newton and this is 100 cube. This is 100 by 1 whole cube. Right, but this is 100 by 1 whole cube. Now if I go for it, if I solve it up, so I'll be getting what? I'll be getting 10 into 100 to the power 3. 100 to the power 3. 100 to the power 3. Getting my point, beta? Getting my point. So what we'll be getting? We will be getting 10,000 kilonewton. So what should be the answer? The answer should be C. That is 10,000 kilonewton. So some of you have made mistake in this question. So can you tell me what went wrong in this question? Why some of you were unable to do this question? Can you tell me, beta, in the chat? What happened in this question? What went wrong, beta? Please answer me what went wrong here in this question. Please feel free to chat. See, if you respond, and the purpose is, see, if you have made mistake here and realize that what mistake you have done and resolve, that's we'll not be repeating this mistake again, and resolve that we will not be repeating this mistake again. So definitely the purpose is solved. Right, beta? Now let's move to the third question. None of you was able to answer this one, and this is perhaps the very good question. Okay, and it is somewhat question of Indian engineering services. Right, I put it there, some sort of with some changes, and this question is a very good question. Okay, so now in a flow condition where both viscous and gravity forces dominate, and both the Froude number and Reynolds number are the same in model and prototype, the ratio of kinematic viscosity of the model to the prototype is 0.089. The model scale Lm by Lp is x is to 1. The value of x is. So, beta, in this both the Reynolds number and Froude number are same. So that means Reynolds number of model, Reynolds number of prototype, both are same. Now we know what is the Reynolds number of model. So it is velocity of model, right? Velocity of model, dimension of model divided by kinematic viscosity of model. Similarly, in Reynolds number, it is Vp Lp upon kinematic viscosity of this model, right? So this is some data we have given. They are saying Reynolds number is same. So we can write like this. Now they are also saying the Froude number is same. So Froude number of model and Froude number of prototype. This is also same. This is also same. Now we also know this Froude number. In this Froude number, what we can say, velocity of model. Okay, root lm, right? Tell me if I am wrong. And g is also there, but I am not writing it because g will be cancelled out only. So this is going to be lp. Vm upon root lm is equal to Vp upon root Lp. So we know the Froude number is nothing but the ratio of inertia forces to the gravitational forces. So from here we can write Vm by Vp is equal to root Lm by Lp. Root Lm by Lp. So from here we can also write Lm by Lp as Vm by Vp whole of a square. Right? This way also we can write. Now moving to equation number one. This is Vm. Upon Vp. Now we can write it like this: Lm upon Lp into or is equal to Vm upon Vp. Can we write this way or not? Is equal to Vm upon Vp. Can we write this way or not? Please answer me. Now this Vm upon Vp into Lm upon Lp into Vm is equal to Vm, that is kinematic viscosity upon Vp. Right, beta. So we can replace this Lm by Lp by the ratio of velocity. Right, beta. So because okay, so they are asking you Lm upon Lp actually. Okay. So now what you can do, you can replace this Vm upon Vp from here. So if I replace this Vm upon Vp from here, so it will be root Lm by Lp into Lm by Lp. So we can write it like this: Lm by Lp to the power 3 by 2 is equal to Vm upon Vp. Okay, Vm upon Vp. Now the ratio of kinematic viscosity of model to the prototype is given to be 0.0829. 0.089. Now solving this equation, if you solve this equation, I hope you will be getting. If you solve this equation, I hope you will be getting 5:1. I hope you will be getting 5:1. So let me check it once. I am not carrying my calculator for today, so I have to do it like this by mobile. Okay. So what we are getting from here? What we are getting from here? What we are getting from here, my dear? Can somebody please help me in this? What we are getting from there? I hope. So we are getting from here 0.2. Right, beta? We are getting from here Lm by Lp is equal to 0.2. Right, beta? What we are getting from here? We are getting Lm plus Lp as 0.2. Okay. Lm by Lp is 0.2. Right or wrong? Right or wrong, my dear? So we are getting Lm by Lp 0.2. So it is so scale ratio. So basically we are getting from here 1:5. That is Lm by Lp. So see, it is somewhat reversed. X is to 1 actually should be 1:x, but I think none of you have given the answer near to it. Right. So the answer to this question is 5. Is that okay to everyone? Please answer me. Is that okay to everyone? Answer me. So it's a good question. In this question, you have to relate with two-dimensionless number. Now moving to the last question. Any doubt in this particular question? See, we have what I have done, Reynolds number related. Then I related this. What you say, Froude number. Then we have related this Froude number. Then we have related this Froude number. And from there we have got the answer. Right, my dear? So any doubt in the particular question? I hope there is no doubt. Now moving to the last one, my dear. So boundary layer thickness at a distance of 100 mm from the leading edge is 6 mm. What would be the boundary layer thickness at a distance 300 mm from the boundary layer thickness is 6 mm. Now, please know this. Now, please, if you remember this, beta, if you remember the concept of boundary layer thickness, so see, beta, we take the distance always from the leading edge, right? We take the distance always from the leading edge, right? So this is what is the trick in this question. So let us say at a distance of, so they said at a distance of 100 mm from the leading edge, means somewhere 100 mm from the leading edge, we have it as 6 mm. This is, let's say this is 6 mm. Now at a distance of 300 mm further to this 6 mm, so 300 mm from here. So now if you remember this delta is proportional to root x, but remember this x is always taken. X to be taken from leading edge. To be taken from leading edge means it is to be taken from here. It is to be taken from here. Are you getting my point, Buddha? Are you getting my point? Right. Now, in the first case, it is proportional to root of 100. Now, this delta 1 is given to you. So, 6 proportional to somewhat, or we can write it like this. Delta 1 is proportional to 100 and delta 2 will be proportional to root of 400. Getting my point, Buddha? Root of 400. Okay. Now, if I take the ratio of it, delta 2 by delta 1 is equal to root of 400 by root of 100, root of 400 by root of 100. So, delta 2 by delta 1. So, delta 1 is given to be 6 mm. So, I think you will be getting 2 from here, root of 400 by root of 100. Root of 400 by root of 100, that is 20 by 10, so 2. So, delta 2 is 12 mm. Now, those who have taken this instead of root 400, so some of you have answered this 10.4. So, if you take x from, if you have taken x at root 300 in the second case, definitely you are going to get the wrong answer. Is this fine to everyone? Please say yes or no. Is this fine to everyone? Please say yes or no. Right, beta? Right, beta? So now we have discussed all these questions. So we have discussed all these questions now. I hope, beta, I hope all the questions are clear to you. And if you have realized the mistake you have made, beta, our purpose is served. Right, beta? Our purpose is served. So in the next session, we are going to talk about the remaining topics. Right, my dear, like laminar flow. So we have a quiz day after tomorrow. So in this, we'll be having the topics of laminar flow and compressible flow. So I am telling you the topic today so that you can come prepared. You can come prepared, right, beta? Right, beta? So now let's end the session. I hope you guys like the session and you find it helpful for your preparation. So please do not forget to like and subscribe the Gate Academy channel and do join with us in the next quizzes also, right? Right, beta. So we have the next quiz day after tomorrow on the same timing. On the same timing. So thank you very, very much, my dear. Thank you very, very much. And we'll see you in the next session with a new quiz. Okay. So thanks a lot. We'll see you in the next session.